And at the end of this video, you should be able to define indices perfectly well, state the laws of indices, and apply these laws of indices in solving questions. Now, if you've gone through past questions, whether JAMB or Waec, you must have seen a whole lot of questions involving the application of the laws of indices in the OBJ. Am I correct? So at the end of this video, when you pick those questions, you should be able to attempt them with confidence. So let's go. What is indices? I believe you have your pen and your paper. Now, if I have that 2 raised to power 3, 2 is raised to the power of 3, we know that it implies 2 times 2 times 2, right? Which is what? 8. Okay, so 2 raised to the power of 3 is equal to 8. Now, indices is actually saying how many times will 2 multiply itself to give us 8, and that is 3 times. So rightly put, indices is the number of times 2 has to be multiplied to give us 8. So this 8 is a value. This 8 is a value. This 2 is a base. Alright? While this 3 is the index or the exponent or the power, as the case may be. So whichever one you call it, you are correct. Okay, so generally put, if I have x to the power of a is equal to y, it means indices or the index a is the number of times x should be multiplied to give us a value called y. So now there's a woman selling banana in your neighborhood, all right? I know, don't ask me how. So now that woman is x. The banana she's hawking on her head is a. Now what is y? Y is the banana woman. Y is what? The banana woman, which is the output. What she gets from selling banana. You don't call her a woman, you don't call her banana, you call her banana woman. That's the value. All right? Good. So having known what indices is, we quickly go to the laws. What are the laws of indices? So the first one, we have multiplication. We have multiplication or the product law. Now, forging ahead, just note that the laws of indices can only be applied when bases are the same. So when the bases are not the same, we have no business applying these laws. So if I have x raised to the power of a times x raised to the power of b, the law of multiplication is saying that the powers can be added given that the bases are the same. All right? So for instance, if you have 2y raised to the power of 2 times 3y raised to the power of 3, applying the laws of indices, you will see that we have 3 and we have 2. They are not the same. So when they are not the same in this case, what do? You put them in a bracket using the sign between the two terms, seal them in a bracket, keep them by the side, and write down the two bases that are the same so that we can go ahead and apply the law. So when these two terms are multiplied together, you have 6y to the power of 2 plus 3, because the multiplication law says we should add the powers, and that will give us 5. Okay, so quickly we move to the next law, and that is division. The law of division. Now, this law of division is saying that given two numbers that are in the same base, and we have the division sign in between the two terms, that we should do what? Subtract the powers. So we have x raised to the power of a minus b. So if we have 2x raised to the power of 5 divided by 3x raised to the power of 2. Now, the same thing that happened in the case of multiplication, we're going to throw these two inside the bracket and go ahead and use the division sign that is in between. So we go ahead and apply the law. So we have x raised to the power of 5 minus 2. All right. So 2 over 3 x raised to the power of 3. All right. The third law is what we call, or what I call, product of products. Product of products. Product of product. So now this product of product is saying that if I have, let's say I have x y to the power of a all raised to the power of b, that this power outside the bracket would multiply the power of what is in the bracket. Now you see that x doesn't have power. So since x doesn't have power, it means that the power of x is 1, right? So we have x to the power of 1 times b, and then y, the power of y is a, right? So we have y to the power of a times b. We have y to the power of a times b. So the result of that will be x raised to the power of b, y raised to the power of ab, and that's our result. So for instance, if we have 2x squared all raised to the power of 3, what would that imply? So you just know that you are not going to be multiplying just this. Remember that this power of 3 is also for 2. So that would mean 2 to the power of 3 times x to the power of 2 times 3. And 2 raised to the power of 3 is what? Is 8. So we have 8x raised to the power of 6. Is that clear? So we'll move to the fourth law, and that is the law of zero index. Zero index. Now, this law of zero index is saying that if x is raised to the power of 0, it will give you 1, given that x is not 0. Given that x is not equal to 0. All right. So it is from this law that we come to establish that anything raised to the power of 0 that is not 1, sorry, that is not 0, will give you 1. Meaning that if you raise that building, that biggest building you've ever seen, to the power of 0, no matter how massive it is, it will give you 1. So you let it be registered in your mind that whatever is raised to the power of 0 is 1. So if I have 2y raised to the power of 0, what would that give me? Because anything raised to the power of 0 is 1, it means that this will mean 2 times 1. All right. So 2 times 1 is 2, because this y raised to the power of 0 is 1 already. Okay. So we move to the next law. Now this next law is power of a quotient. Power of a quotient. Okay. So this power of a quotient is saying that if I have x over y raised to the power of a, that this power of a will not affect just my numerator, but it will affect both the numerator and the denominator. Okay, so you see why indices is a fundamental topic in maths. You see? So if I have 2 to the power of, 2 over 5 to the power of 3, for instance, what would this mean? Will it mean 2 raised to the power of 3 over 5? No, it will mean 2 raised to the power of 3 over 5 raised to the power of 3. And 2 raised to the power of 3, we already know that it is 8. That is 2 in 3 places. While 5 raised to the power of 3 is 5 in 3 places, which is 1, 2, 5. I believe this is clear. Okay, we move to the next law, and that is the law of negative index. Negative index. Now, this law of negative index says if I have x raised to the power of minus a, that I can write it in its inverse form as 1 over x raised to the power of a. Now, writing it in this form has made me not to write it with that negative sign. That's the essence of this. Now, why is this law important? Let's look at an example. If we have 2 raised to the power of minus 3, remember this was the example I used to define indices, right? Good. So if I have 2 raised to the power of minus 3, what does it mean? How many times, remember that this power of minus 3 means how many times 2 has to be multiplied to give a value. Can 2 be multiplied in a negative way? Is it possible to multiply 2 in minus 3 ways? So now I will have to write it in this form. 1 over 2 raised to the power of what? 3. So when I write it in this form, the question now is how many times will 2 be multiplied to give me 8? Instead of saying 2 will multiply itself minus 3 times. Alright? Now the last but not the least, we have the law of fractional index. Fractional index. Now this fractional index law is in 2 forms. The first one, if I have x raised to the power of 1 over a. Now in this case, I have a fraction as my index or my exponent. So what happens? The denominator becomes the root. Okay? So since 1 is my numerator, in fact, every whole number has 1 as its power, right? Okay. So this is equal to the 8th root of x. So whether I raise it to the power of 1 or not, it's still the same. But then what if something other than 1 is the numerator? What happens? Let's look at that case where I can have a over b, right? Where a is not equal to 1. That means this will become my power, while this will become the root. So that means I will have the bit root of x raised to the power of a. All right, now we're going to be picking a few Waec questions to see how these laws can be applied. Now, you need to know the laws. Why? Because in a question, nobody will tell you apply the first law or apply the multiplication law or whatever. Also, you can also actually apply more than one law while solving a question. So we look at a question very quickly. The first one says 16 raised to the power of minus half times 4 raised to the power of minus half times 27 raised to the power of 1 over 3. So if you look at this question, the law that should come to your mind is the law of fractional index. But before then, as you're looking at the fraction, you'll be seeing negative sign, right? So it means we should take care of the negative before we come to fraction. So considering the law of negative index, the first term there becomes 1 over 16 raised to the power of half times 1 over 4 raised to the power of half times 27 raised to the power of 1 over 3. So now remember the law of fractional index, that this will be the root, right? Good. So we have 1 over the root of 16 times 1 over the root of 4 times the cube root of 27. Okay, so the root of 16 will leave us with 4. So we have 1 over 4. We have 1 over 4 times 1 over 2 times 3. So this one doesn't have a denominator. So let's assign 1 because the denominator of every whole number is 1. Okay? So 1 times 1 times 3 will give us 3. 4 times 2 will give us 8. And that is the result. So the second question, before we look at the last one, we have the second question. We have if, this is a Waec question, if 27 raised to the power of x times 3 raised to the power of 1 minus x all over 9 raised to the power of 2x, and this whole expression is equal to 1, we are to find x. Okay, so now if you have this kind of question, what comes to your mind? The first thing to do is to cross multiply. Okay, so the second question says if Munachi mechie ọnụ gị ebe ahụ. Shut your mouth, stupid human being. Ọ bụ na na-eji gị. Mgbe ahụ gasị na m achọghị mkpọtụ, mgbe ahụ ka ọnụ gara agba gị bebebebe. Okay, so the second question we're going to be solving is this. So if this expression on the left hand side is equal to a raised to the power p, b raised to the power q, c raised to the power r, we are to find p plus 2q, right? Good. So looking at this, the first law that should come to your mind is product of product. It is with that law that you open up the bracket. So doing that, we will have, now we're facing the numerator, right? So we'll have that a raised to the power of 2, and then we'll bring up the denominator. Bring up the denominator. So now, what is the next law coming to your mind? That should be the quotient rule. All right. Why? Because we have division. And that law says that when you have division, you subtract the powers. So having known that, we will have, so having known that, applying the division or the quotient law, we will have a raised to the power of 3 over 2 minus 1, b raised to the power of minus 9 over 4 minus 4. And then we'll have c raised to the power of 3 over 4 minus 5. Okay, simplifying further, minus times minus gives us plus. So we have a raised to the power of 3 over 2 plus 1. Okay. Then for this one, we have b to the power of, let's take LCM. We have minus 9 minus 16. For this one also, we'll take LCM. The LCM of the denominator is 4. LCM of 4 and 1 is 4. So here we also have 3 minus 20. Okay. So that will give us a raised to the power of 5 over 2. Don't mind my signature 5. B raised to the power of minus 25 over 4. And then 3 minus 20 will give us minus 17 over 4. Good. Now we have simplified what we have on the left hand side. So equating it with what we had on the right hand side, which says that a is raised to the power of p, b is raised to the power of q, and c is raised to the power of r. So if these two sides are equal, because we have the equality sign, it means that p is the same as 5 over 2. Do you get that? Q is the same as minus 25 over 4. And then R is the same as minus 17 over 4. And then the question says find P plus 2Q. So having known what these letters stands for, it is very easy for us to substitute. So we have P plus 2Q as 5 over 2 plus 2 into minus 25 over 4. So 2 divided 4 will give us 2, right? So we have a minus sign and a plus sign outside. So minus times plus is minus. So we have 5/2 minus 25/2. So when you have two fractions to add or subtract and the denominators are the same, you simply work on the numerator. So we just have 5 minus 25, and that will give us minus 20/2. Minus 20/2 will leave us with minus 10. Simple as ABC. I hope you enjoyed it. Okay, I'm gonna drop two questions for you to try. Please do well to try them. All right. So I want you to try out these questions, just these two. So when you try them out, please drop your answers in the comment section. If you encountered any challenge while solving or while going through these ones we did together, also let me know and I will put you through. If you also need further explanations, please do not hesitate to reach out. Bye. See you in the next video. Please do well to subscribe if you are yet to, and invite your friends too.